Go.
Hi, everybody. We're going to just take a few minutes to let more people get into the webinar, and then we'll get started. Just give it a little bit more. Let more people in, then we'll get going. All right. Hello and welcome to today's presentation on agriculture and solar photovoltaics, also known as dual-use solar or agrivoltaics. Thank you for taking the time to be here today. We're going to hear from VP of Commercial Business, Nick Darbeloff, about the ins and outs of a dual-use project, then turn to Nate Tassinari for an up-close look at his own agrivoltaic array in Munson called Million Little Sunbeams, to learn about his experience with installation and maintenance of this kind of system. There will be time for Q&A at the end of the presentation. Feel free to drop any questions into the Q&A section of your Zoom window during the presentation, and we will cover what we can with the time remaining. In addition, this webinar will be recorded and available on our website later on. And now I'll turn it over to Nick to get the presentation going. Nick.
Thank you, Lydia. Welcome, everyone. Let me just get my screen going here. There we have it. Great. So thank you all for joining us today. As Lydia noted, we would love to have any and all questions from you. Please post them in the chat or the Q&A section of the Zoom taskbar you see down there, so that we can gather them and make sure we answer them at the end of the presentation. As Lydia noted, our focus today is dual-use agrivoltaics. And we're going to talk through a number of topics today, including a little bit about what that means, some history of it in Massachusetts. We're going to position it in the world of solar in terms of what we might call big solar and small solar. Most important, walk you through the economics and including a little bit on purchase versus lease of your land, and then talk about how such a system gets configured, the amount of land required, and just walk through a couple issues and obstacles. We'll then take a look at Million Little Sunbeams in Munson and talk to Nate Tassinari, who is the owner. And I'll note that we're actually going to use Million Little Sunbeams as the sort of case study as we move forward. A quick note on Sunbug, just so you know who I am and we are. We are a solar systems provider that was founded in 2009. We've installed well over 3,000 systems across Massachusetts. We got in early, largely because of Nate's interest in building a dual-use system into the agrivoltaics arena. And we have a number of additional such systems in development. We're excited about the opportunity, and we hope you will be too. So, jumping in here. Agrivoltaics, simply the combination of those two words, also called dual use. And what it means is the use of available farmland for both collection of solar energy and growing of a specific crop. The crop can be really anything you choose that's compatible with limited sunlight. The case study we're focusing on today in Munson is growing hay. Here's a look at that same system from the air. And since we are using it as our focus today, I'll tell you that it's a 250 kW system. It's using single axis tracking, which means the panels point east in the morning, are horizontal at noon and point west in the afternoon, so they track the sun. It also uses bifacial panels, which means that they're somewhat translucent. The biggest feature there is that they are collecting energy on both the top surface and the bottom surface. So reflected light actually helps generate electricity as well. And then the last, little technical, but they're optimized, which means that every panel produces to its optimum ability. Oftentimes you'll have panels grouped in such a way where they are constrained by their neighbor, and groups of panels will only produce, each panel will only produce as much the lowest producing panel in that group. And that's the last I'll say of that. Some history. The SMART program was introduced in 2018 as a means to accelerate solar in the Commonwealth. SMART stands for Solar Massachusetts Renewable Target. And to encourage dual use, the program has an adder, as it's called, for solar systems installed over farmland, which is fairly generous. We'll take a look at that in a sec. The first systems came online in 2021, and there's an ugly acronym for them called Agricultural Smart Tariff Generating Units, or ASTGUs. I don't think I use that much in this presentation. So, positioning this in the world of solar. Small solar, if we look at rooftop solar, can be anywhere from 5 to 25 to actually 100 or kW or more. Large manufacturing facilities can be extremely large. You might have a large barn that could accommodate 100 kW on a nice south-facing surface. One key issue here is that they use no land because they're on an existing facility. Big solar, if you will, or a solar farm, is typically, it can really be any size, but it's typically 1 to 5 megawatts. And the 5 megawatt is not a limit, but in Massachusetts, there's benefits to staying within that limit. So it's a de facto ceiling in our state, and that will take about 5 to 20 acres. A megawatt of solar typically takes 4 to 5 megawatts, 4 to 5 acres each. Now, the small solar or rooftop solar is typically configured behind the meter, and large solar farms are typically configured standalone. And we might take a quick look at what that means. Behind the meter means that when solar energy is generated, it flows into the facility. So if the facility is using electricity at the time, the solar will be first used by the facility. If solar being produced is more than what the facility requires, it will flow through the meter and out to the grid, and the owner will get credited back for what is put out on the grid. If the solar being produced is insufficient to match the load of the facility, then additional electricity will be pulled in from the grid. Fairly simple arrangement, very efficient in terms of using the grid, if you will, as a solar energy bank. Standalone is quite simple. It simply means that solar is exporting directly to the grid, and the off-taker, if you will, in other words, the entity that is consuming the power or receiving and buying the power is in fact the utility. There is a meter involved, but I left it out for reasons of simplicity. So there is no facility involved that's taking off some of that electricity. It's just going straight to grid. Now, for today's focus, which is a 250 kW system, it could be either behind the meter or standalone. 250 kW is a lot more than the average home, but it's quite possible on any number of farms that there are facilities within your operations that are consuming a great deal of power. And for a 250 kW system to sit behind such a facility is quite possible. It can also be standalone. The system in Munson that we'll be discussing throughout is standalone, and it takes up 1 to 2 acres. One quick note on all this. Our goal today, while we're going to be focusing on this 250 kW system, the goal is not to in any way discourage adoption of any other type of solar. All solar is good. If you believe that putting solar on a barn or fixed ground mount or a large solar farm is the right path for you, that's fantastic. We simply are presenting this as one means to deploy solar. And it's worth noting that as a mid-range system, it has some benefits of being not too large, not too small, and providing economic benefits that I think you'll find compelling. So let's get into that. Obviously, when people think of solar energy, they think of the solar panels generating electricity. This, of course, is correct. However, because of incentive programs like SMART in Massachusetts and federal tax benefits, which provide other sources of income, it's a good idea to look at solar as generating revenue. So when you think of solar, think of it as one additional income stream for your farm operations. And it can be significant. Let's walk through how the SMART program works. And what we're looking at is a 250 kW system in national grid. Eversource will actually be a little higher, and throughout we're going to try and be a little conservative in our numbers so that actual performance would be higher. The SMART tariff for a 250 kW system in national grid will offer 16 cents per kilowatt hour. Now, the generous adder for agricultural dual use systems is 6 cents. So basically sort of a, nearly a 40% bump. 30% bump. And all in, it's 22 cents per kilowatt hour. And this would be a front of the meter or standalone system. And we do that mostly for simplicity. It would be similar for behind the meter. There's just more sort of boxes involved, if you will. So at 22 cents per kilowatt hour, and I want to explain what I mean by kilowatt hour. I think some of you may be familiar, but when we get our bill every month for really anything that's consuming electricity, any facility, it's going to tell us how many kilowatt hours or kWh we consumed in the last month. Simply put, 10 100-watt bulbs burning for an hour is 1,000 watts for an hour is 1 kilowatt hour. And we tend to use 450 to 750 kWh per month in our homes on average. So 22 cents per kWh, and the system will generate approximately 450,000 such kilowatt hours per year, resulting in income of just under $100,000. And on top of that, federal tax benefits are quite generous as well for solar. Actually, the investment tax credit, or ITC as it's called, was just bumped or restored to 30%, and it will be at 30% for the next 10 years per the recent federal Inflation Reduction Act. Depreciation will provide another 25% of system cost back into your pocket. So what that means is that for every dollar you spend on a system, you're actually only paying 45 cents, which is pretty compelling. So we put all that together, and we assume that a 250 kW system that we're discussing today costs $1.1 million. The ITC and depreciation, as you can see, take off quite a bit of that, and we're left with $495,000 as the net cost of the system. So if we then follow that through, we're producing $450,000 per year. We're breaking even in year 6. After 10 years, the system has put $460,000 in your pocket. And after 20 years, it's put $1.4 million in your pocket. So I assume there are going to be some questions on this, but we're going to take them at the end. And we can talk through any other issues or questions you may have. Now, when you're purchasing a system, you've really got two choices. You can purchase it, or you can have a third party purchase and own it and lease your land from you. There are pros and cons. If you are having a third party purchase the system and you are leasing land to that third party, there's no capital required from you, which is quite convenient. You don't have to take out a loan. You don't have to extend your credit. And of course, the investor or owner maintains the system. The downside here is you lose some land control. Obviously, the owner is going to mandate that it remains on your land for the full lifetime of the array. They are going to have access to it. You're going to be limited in what you can do with that land for the lifetime of the system. And the returns are lower. So for the 250 kW system we're talking about, you might expect to gain about $15,000 per year. It could be higher, could be lower, depending upon the market at the time. If we compare that, a lease is going to put about $300,000 in your pocket over 20 years, whereas purchasing it is about 1.4 million, as we discussed earlier. So, two options if you're purchasing. One is a loan, and a loan requires that you have a tax appetite for those federal tax benefits. The good news there is that depreciation is typically taken over a 5 or 6 year period, and the federal ITC can be taken in the first year if you've got the tax appetite for it, or it can be pushed forward for a period of up to 20 years if your tax appetite is lower and you're going to consume that tax benefit over time. When you use a loan, the good news here is that the system income, the revenue that the solar system is generating will exceed your loan payments. So it is in essence paying for itself. If you do not wish to harvest those tax benefits, or you do not have the tax appetite or liability for those tax benefits, then you can use what's called an operating lease. And that's where the lender actually takes the tax benefits. So they actually own the system for the duration of the loan, but you are receiving all benefits of the energy generated. Again, the system is going to pay for those lease payments. And because the lender is taking the tax credits, you're actually paying back. The loan principal is less than the system cost to make up for the fact that the lender is getting all those tax benefits. I have the Farm Credit East logo up here solely because it is one lender who understands such operating leases. There's a few folks who understand such operating leases in Massachusetts, but I'm guessing you're familiar with that lender in specific. There's also grants available for such systems, which can have a nice, comfortable impact on reducing system cost. And you can go to the USDA for a REAP grant, and MDAR has some other grants as well. So I'm going to talk a little bit about how such a system is configured. I think we've all seen what we might call ground mount solar, whether it's in a farm, in a field on a farm, or whether it's by the side of the highway, as is now common in Massachusetts. This is fixed racking for the solar panels. The lower edge is typically 3 feet off the ground. For a dual use system under the Massachusetts guidelines, they're much taller. So a fixed system, the lower edge would be 8 feet off the ground. If we're using a single axis tracker, the axis would be 10 feet off the ground. And the reason for that's pretty simple. A, we want light to come in under those panels, and B, we need to be able to farm and work the field using our equipment. So one point worth making is that a single axis tracker is more expensive than a fixed array. So the question is, why would you do it? And the answer is pretty simple. A single axis tracker can follow the sun across the sky during the day, whereas a fixed panel cannot. And as a result, it's going to generate a great deal more kWh per year. And that equates to a lot more money. So 25% more kilowatt hours, $20,000 more money in your pocket each year. And again, I'll point out that that's a combination of single axis tracking, bifacial panels, and optimized individual panels. Here's a look at the Munson system. You see that they are tracking the sun. In this case, it's noon. You can see those shadows directly underneath the panels. And that shaft in the background is the drive shaft. So that is actually what is driven by a controller and a motor. That is what is actually causing the panels to tilt and follow the sun throughout the day. The boxes we see up front are the inverters. And you'll note that we can see on the bottom of the panels that they have glass backing. So what that means is, as sun is reflected off the ground, it will actually collect electricity from the underside of the panel as well as the top side of the panel. In summer, this makes a difference. In winter, it makes a huge difference. Winter is typically a low production period for solar, but if you are using bifacial panels, all the reflected light from white snow can generate a great deal of additional electricity. So I'll talk about how much land we're consuming here. The 250 kW system that we're using as our case study consumes about 1.5 acres. And you see the rough dimensions of the field there. It needs a healthy border, both east and west and south. So sunlight hits it early in the morning and late in the afternoon. You want some southern exposure because the sun is low in the sky in the shoulder months or fall, winter, early spring months. We offer some additional dimensions there. You'll note the panels are about 6.5 feet in length, and the row spacing is about 16 feet. Now that row spacing is exaggerated, and I'll come back to why that is the case. For a larger system, say a little over 2.5 megawatt system, it would use about 13.5 acres if it was configured with the same technologies, single axis tracking, etc. And there's no reason not to do this because a great deal more income will be generated from a larger system. One element of the SMART program, however, is that it is tiered. So small systems between 25 and 250 kW will receive 16 cents per kilowatt hour. And as systems increase in size, that is reduced, wherein the largest system, 1 to 5 megawatts, is only 10 cents per kilowatt hour. And thus, there's a reason for keeping it 250 kW AC or below. Another element here is interconnection approval. In Massachusetts, a lot of solar has been installed, and interconnection approval can both take a while and cost money, where the utility can charge you for any upgrades they need to make to the grid in order to accommodate solar at a given location. For a smaller system, it's a fairly straightforward process. As you move up in size, the amount a utility might charge you increases, and it also might even be years before approval, largely because in some areas of the state, especially rural areas where substations are not equipped for a lot of traffic of electricity, new substations have to be built before such projects will be approved. Some of you may have encountered that. So one other note on the SMART requirement put out by MDOR and DOER is that when the system is installed or the system is built, it must accommodate 50% or more of the solar that was hitting it previously to reach the ground. And that's one reason why the panels are spaced, the rows are spaced further apart. And the field must be of a size to ensure that that requirement is met. So if you've got a couple of acres, you can't jam them full of panels if you want to be a dual use system. You've got to space them in such a way that you meet this requirement. And that's one of the reasons why single axis tracking is important here or valuable. It's because we're making the most out of available land. So some basic issues that are typically encountered when you're building such a solar system. One is wetlands, actually true of anything you might build, whether it's a building or a solar system. There is the Wetland Protection Act at the federal level, which says you can't build on or near a wetland, and the town's Conservation Commission will get involved and ensure that the Wetlands Protection Act is complied with. Another requirement of the Massachusetts SMART program under dual use is that the land must have been used for agricultural purposes prior to the installation of the system. And once the system is installed, it must continue to be actively harvested. And if it's not, it could be audited and it could risk losing that 6-cent adder. In other words, it could drop away if the owner is not, in fact, using it for agricultural purposes. Decommissioning is where some towns will actually ask the system owner to put aside some monies in order to ensure that the system can be removed upon end of life. It's a somewhat frustrating requirement, but it makes sense. And not all towns require it, but some do. And the last is three-phase power. Power along roads in states across the nation are either three-phase or single-phase. And a solar system of this size really needs three-phase power. If you don't have it where you might put a solar system, that could be a showstopper. Three-phase can be brought in, especially if it's nearby, but it can be a sizable expense. And the way you tell is at the very top of the pole are the power lines. The lines lower on a pole are for other purposes. At the top, if it's one wire, it's typically single phase. If it's three wires or cables, it's typically three-phase. Not always the case, but usually the case. I'll point out that single-phase power is not always a showstopper. The system we're discussing today did not, in fact, have three-phase power, and we had to bring it down the road a ways. But the system economics were able to accommodate that extra cost. And that is the end of my section. I'm going to ask Nate Tassinari to join us. Hello, Nate.
Hi, Nick.
And Nate's going to talk a little bit about his system and why he decided to move ahead with it. Thanks,
Nick. Thanks, everyone, for listening in. I thought I'd start with where is Munson? So Munson's my hometown. I grew up there. It is one of the first towns in Western Mass. As you head east to west, you can see the little star there on the map. It's a beautiful hilly town that was full of farms, and here's the town is the old granite quarrying town, quite a nice place to grow up, and I was very happy running around the fields of town as a young boy being there. My great grandfather had bought a dairy farm in Munson around the turn of the century. And this is actually roughly a look from the top of the hill where our farm is, around that time period of what the town looked like. As I said, there were dozens and dozens of family farms at the time. And my great grandfather, Tom Murphy, was one of them. My grandmother was raised on that dairy farm, and around the 1950s, she bought the dairy farm next door. So my family, in fact, had two dairy farms next to each other. And, so of the land that my grandmother owned, she had about 200 acres, and about 50 of those acres were used for silage and for hay to support the dairy operation that we had nearby. Go ahead, Lydia, next slide, or Nick, whoever's in charge. So yeah, there's a little snippet there of my great grandfather, Tom Murphy, and you can sell. He's also selling potatoes here. He's a milk dealer. So as we'll stop here for a little bit. So as my grandmother got older, I really wanted to protect that land and keep the land in farming and keep it in the family. And so I bought it from her before she passed away, and I was kind of stuck with the situation where I wasn't living in Munson at the time. And now I'm just footing a large tax bill and letting my cousins who still run and operate that dairy farm use my fields. And I felt like I needed to come up with a way to support my field and my farm economically without just taking it out of my paycheck every month. So I investigated a few things. I'm sure a lot of you have done the same. I looked into the APR program. I drew up some maps to what if I sold some lots for different houses and things like that. And about that time, I became interested in solar. I had solar on my house, and I had gotten to know the folks at Sunbug Solar. And I said, hey, we really appreciate, could you take a look at my land on a map and let me know whether there's any opportunity here to put in solar? And this was actually a little before the SMART period. It was before the SMART program had come out. And we were just kind of investigating a little bit. as that SMART program came out and the more of the details came around. And because of a few things that happened in town politics and the zoning and things happened, eventually we decided to investigate building this array in one of my back fields, in one of the hay fields in the back. My day job, apart from owning this farm and doing some orchard work, is I work as a banker. So I started to put together the numbers to say, all right, what if I built this myself? I didn't like the idea of selling or leasing my land to somebody else. I wanted to keep it in the family and keep control of it. This field that you're looking at, it abuts the back of my grandmother's house. So I didn't want to have somebody else going in and out of my land all day. You can also note here, I think one thing we don't really talk about here is there's no fences. This is just open access. So, deer and turkey and animals run in and out of this. It's just as much open farmland as anything else around. But anyways, going back to the focus. So, we investigated it, and one thing that wasn't really emphasized is the tariff that you get, the payment that you get for the electricity that's going back to the grid is guaranteed for 20 years. So as I was investigating this, I said, okay, if I pay for this over 20 years, can I make this happen? And it turns out I can. And so we're working with Sunbug. We designed this system. We installed it. I've had to buy a couple different pieces of machinery to accommodate getting in and out of the poles there. So that was a little bit of an extra expense, but today we're happily haying this field, making bales of hay and delivering it to the cows. The solar system is outperforming all the expectations that we had. It's doing very well. It pays the loans that I took out on it. I used an SBA 504 green loan to finance this project. Again, I own it. Me and my wife own it as owners of the LLC. We technically lease land from ourselves as part of the process, but essentially it's all owned by us. And as I said, the economics of it have really worked out for us. It's sufficient to pay the taxes on the land and help us keep the farm open and free without any restrictions on the land use. Some of the issues that we had, Nick had his slide earlier with some of the issues and talked about wetlands. And so there are some wetlands around, but we were just strategic in it. And because it's open land, we were able to kind of work around and find the right places to do that. We did have to bring the 3-phase electricity in. That just meant working with the utility to bring a couple poles over. I'm not going to say that was an easy process, but we got it done and it was worth doing. The farm, in terms of the land, was already in 61A, so we already had it designated as farmland. So we didn't have any problems working with MDOR to satisfy that. And largely the fields are continuing to operate as they had in the past. And I'll tell you that anecdotally, the grass here that you're seeing under the array this year, because it was kind of a dry year in our little corner of Massachusetts, it actually kind of outperformed some of the fields around it because of the shading. It actually benefited some of the hay. I'm not sure that would be the case on an average year when you get a normal amount of rain, but this year we saw, anecdotally, a slight increase in the amount of hay produced there. I'm going to stop there because I see there's 19 questions and I hope they're all for Nick. Here's just one more look. There's my tractor and there's a look at the array from the back of that house. And you can kind of see the orchard I have there in front that I'm growing. But yeah, it's been a pleasure to build, and we're all very proud of it. And thank you for your questions and your attention.
Thank you, Nate. Lydia, maybe you could join us and help us with questions.
Yeah, so maybe for the first move, can we move back to the income generated by solar per kilowatt hour just while we answer some other questions? There were some people who wanted to just take another look at that.
Good. Take a sec to do. I'll tell you what, why don't we hold on that one?
Sure. Next one, could you go over what depreciation is?
Sure. So actually, Nate, I'm going to give that to you, who understands depreciation better than I.
Okay, Nick. So when you buy an asset or you build an asset like this solar farm, it goes onto your balance sheet, meaning, and it could be anything. We'll use a solar array. So let's say this is $1 million array. But when you buy that, it doesn't count that year as an expense to your business. It's not like buying gasoline. It's like buying a long-term asset. And each year, that asset becomes less and less valuable, and you get to take a bit of that loss each year, and it offsets your income. So I'll use a very, very simple example is if this was $1 million array and you depreciate it over 5 years on an even template, each year you could write off $200,000 of income off of your taxes. And there's a significant benefit each year of not having to pay income on that income, pay taxes on. Excuse me.
And that's how that 25% of system cost is derived and reduced as a tax deduction.
Great. The next one was asked during Nick's part of the presentation. For your financial example, did you include the cost of borrowing money?
We actually did not. So that was a straight purchase, assuming cash, and it's an excellent question. So obviously, cost of capital is going to bite into returns, and we live currently in an age of higher interest rates, so that's impactful. I know Nate's system was purchased at a time when interest rates were lower, but cost of capital will invariably have an impact on returns.
Next one is SMART funded in future years?
Yes. So as Nate noted, and I mistakenly did not point out, the SMART program is guaranteed for 20 years. SMART is what's called a declining block program. I'm not going to explain that, but suffice it to say that SMART will run its course. But if you are leveraging SMART, as soon as you lock in your SMART qualification, you are locked in for a period of 20 years, and it's guaranteed for that 20 years. The odds that anyone is going to undo that is extremely low because the state would be cutting off investors at the knees. So it is dependable.
All right, next one. Does sunlight reduction for spacing account for diffuse light as well as direct?
Good question. I don't think we know. The bifacial panels, as Nate noted, the system is outperforming expectations. Nate and I had many discussions in the early days about the economics, and there's a multiplier that tells us, how much a system is going to produce. And I kept pushing for a low multiplier, and Nate was confident that it would be a higher multiplier because of the technologies we were using. And as it turned out, he was right, but in fact, we were both wrong. It was higher than even Nate's higher estimate. So I think that the answer is there's clearly benefit to bifacial panels and clearly benefit to tracking the sun and optimizing panels so that each one can perform to its optimal ability.
Next one is, if the panels are third-party owned, does the third party have to set aside the funds for decommissioning per town regulations?
Yes. In other words, if there's a decommissioning requirement, then that will be made of whoever owns the system. And it's always a back and forth as to how much money is going to be required to decommission the system. And I won't comment on how much that is because it's going to be a different negotiation in every town. It's not a ton of money, but it's not insignificant.
I think it's, so let me add here that, Munson did not require that of me. And I'll also add that, solar panels have life, 25-year or 20-year warranties. And long after the 20 years have passed and the SMART program stops paying me those incentives, I intend to, figure out, I don't know how much it's going to pay me, but I'll still be producing electricity and still be selling it to the grid. So there'll be no decommissioning of this system anytime soon if I can help it.
Panels should last 30 years. Some say they'll last 35 to 40. Obviously, it depends upon weather conditions and any other number of factors. But as Nate notes, there's a federal statute that basically says any generating system, solar, fossil fuel, other, is allowed to sell its generated electricity to the grid at the wholesale price. The wholesale price bounces around a lot. I think it's currently at 5 or 6 cents. It's been as high as 7 or 8 in the past, and my guess is it's going to go up significantly in the years to come. So when all of this lapses, Nate will be at liberty to sell at the wholesale price, even when all incentives have faded away.
Next one is, what proportion of agricultural production must be maintained on the property?
What proportion of,
I'll try to jump at that.
right?
When you present your plan to the DOER, you have to work with MDOR to submit a farm plan. And it's really at their discretion if they agree with your farm plan. So basically, from my understanding, they're just looking for you to actively use the land underneath the array as you were before, or as newly intended, and it has to make sense. They are a farm first organization. They're not particularly interested in how much electricity you're generating or the economics of the solar array. They want you to keep farming. So if you're, as it applies to the land under here, they want me to get as much hay from that as I possibly can. And you can see in this picture that's up on the screen, right around the poles there, I need to do a better job of collecting that hay, which is why I had to get a new mower. So that's a long way of answering. They really want you to use all the land under the array to continue to farm. You can't just say, hey, we're going to do 60% of it and ignore the rest of it. They really want all of it to still be farmed.
Great.
So this one we spoke a little bit about, or Nate, you spoke to a little bit, but I'm curious if you could go back in time a little bit. Someone was asking, has hay production been affected at all?
Yeah, anecdotal, no, not in a particularly measurable way. I have been working with UMass, and UMass is starting to do a study to measure the hay production or growth underneath versus not underneath. So we'll have more scientific answers in the future. But anecdotally, as I count bales, it's not a particularly easy thing to count, but I can't really see a discernible difference.
Great. And this one's also for Nate. How long has the system been operational, and has performance decreased at all?
So it went into service 2 years ago in September, so a little over 2 years. And I think the answer to that is no. It's too early to say. I have a monitoring system, and I know what I produce each month, but I've only been doing it for 2 years, so I can only say that last year was not nearly as sunny as this year. So this year I'm producing a lot more sun than last year. I think over time I'll be able to see some degradation in the amount of electricity being produced as is anticipated, but I know nothing significant.
Right, and it's worth noting that solar panels have a degradation factor. It's very small, but what it means is that a panel will produce a little bit less year over year over year due to expected and actually qualified or quantified degradation. It's like driving a car off a new car lot, and 10 years later it's still running like a top, but you're not getting quite the mileage you did when you bought it.
This one's for Nick's part of the presentation. What is the source of smart money? Is this solely through ratepayer money?
Oh, that's a good question. I mean, it is through ratepayer money at the end of the day. In other words, the utility incentive programs are typically derived from a small adder on all ratepayers' bill. There's huge arguments over this in I assume every state as to whether or not that's burdensome for other ratepayers. In point of fact, solar is actually quite valuable to the grid overall as a smoothing agent. In that, I don't want to go into too much detail, but suffice it to say because the amount of solar electricity in Massachusetts, as it grows, means that less fossil fuel is required to supply the state. It's actually reducing rates for all ratepayers. So there's a balance here. But at the end of the day, yes, it comes from ratepayers.
Right. And what would you say is the output to the grid compared to nameplate on average over the course of the year?
Well, I mean, nameplate is, there's nameplate power, and I probably should have explained this early on. Kilowatts is energy or power. Kilowatts is power. Kilowatt hours is energy. So if power is what it's producing at any given point in time, kilowatt hours is the sort of bucket of energy it's creating over time. And the nameplate of the system is 250 kW, but the amount it produces is in accordance with its specific yield or production ratio. And that production ratio is that multiple that Nate and I batted back and forth in the early days, where we were pushing for a conservative multiplier. He was pushing for a less conservative one, and it came in higher. I'm not sure I answered the question crisply, but that's how nameplate is typically referred to, the KW of the system, not energy production, which is kWh.
And if we're talking about this specific farm, the presentation that it was given was largely accurate. This is a 250 kW nameplate system, and this year is going to produce plus or minus 450 megawatts. So that's more or less in line.
Who pays for upgrade to 3-phase wires?
I did.
Great question. Nate does. I don't want to get into too much detail here, but the way solar gets installed is through what's called cost causation. If you're putting in a system and you're causing the need for a grid upgrade, you pay for it. Under the climate bill that's passed this past summer in Massachusetts, we're going to move to cost allocation, where the utilities are going to be at liberty to upgrade the grid in various locations without pinning it on specific projects. That will take some time to move through the system.
Are there many towns where decommissioning is not required?
Yes, as Nate noted, Munson is one of them. And, I think that you'd have to do sort of a survey of the bylaws of all towns. Some towns will copy each other's solar bylaws, which makes sense because some towns have done good thinking on it. So it really just has to do with doing a bylaw search, or if you do your town's name and then add next to it in your Google search solar bylaw, you should be able to dig into the details and see whether there's decommissioning required.
And I think it will vary from town to town based on the size of the project. Sometimes they'll say anything bigger than XYZ will have a decommissioning requirement.
Have you done soil testing before and after the panel installation? Particularly interested in potential compaction and the impact of the hay yield in wet years.
So I'll start by saying soil testing, or what's called geotech, is done for every ground mount solar system. But that's a slightly different animal. What that's doing is looking at the soil and understanding from an engineering perspective how far down those posts need to go in order to provide the rigidity necessary to stabilize the system. So it's just an analysis of soil to understand the engineering of the system. As for whether compaction impacts the hay, I'll put that in Nate's lap, but I'm not sure that's an easy question to answer.
I'll let you know. I think that's one of the things that UMass is very interested in, and that may be part of their study. I don't think that we have an answer to that question. I can tell you that there certainly was compacting, that happened at at the site there when we were building. It wasn't nothing, but these I tell you, there's been tractors driving over these fields for compacting the soil for 100 years. So I don't know.
How long did it take for this system to come online?
Great question. It took a couple of years. I think part of that was due to the fact that Nate was an early adopter, and we drove into this really before the state had answered all the questions around its own program. And UMass and MDAR were all involved, and there were solar radiance tools that had yet to be developed when we started the process. A lot of the guidelines had not been finalized, so it was released a little prematurely, but we worked through it. I'll give you the following sort of rule of thumb. If you decide to go ahead with this project, the interconnection approval is probably going to take somewhere in the neighborhood of, I'll say, 4 to 10 months. It sounds like a huge range, but you're sort of at the utilities. I mean, it's entirely on the utility to figure out how and when they're going to approve a system. So it can take quite a while, or if their load is lower, they might be able to move it through the system a little more quickly. Once you have interconnection approval, you're going to lock in your smart rate, and you're then going to begin spending all the money to test the soil and work with Conscom to get your approvals and so forth. And that's going to take another, I'll say, 6 to 8 months, and then you're going to procure and build. So it's not going to happen in less than a year. A year and a half would be, I think, quite efficient. But you should expect that it's going to take somewhere between, a year and 2 years. What do you think, Nate?
Yeah, I think that's fair. Year and a half, 2 years. The actual build took longer than we anticipated because we were learning a lot of things.
Right.
But I think it's only a couple months at max of actual build time. Depending, we ran into a lot of rocks. So every site is different.
And we had to drill, but we now know that, and so we know to have a driller on site.
Right.
If you built under the SREX, do you still get that rate for 20 years?
SREX was a 10-year program, and an entirely different program. So if you built under SREX, you are allowed to what's called mint SREX for 10 years, but it really has nothing to do with how solar is built today. SREX are a program of the past and no longer relevant to any new systems.
In Massachusetts.
In Massachusetts, correct. And they may return to Massachusetts, but the current program is not SREC driven. Solar renewable energy credits, for those who are interested.
All right. How much electricity generation decreased with this agrivoltaic design versus if you design the same area for just solar? Did agrivoltaic design require extra open area for access to roads?
That's an excellent question. And we kind of touched on this. If you were to do a traditional ground mount system, the density of the panels on the land would be much higher if you didn't have to meet the smart requirements. However, I would hold that Nate's system is outperforming even a dense ground mount system because of those added technologies. In other words, because it's using trackers, bifacial panels, and optimization, it's going to be very, very competitive with the densest of arrays on a given amount of land. Now, if you were to not have that, you could still use trackers and all those technologies without the solar radiance requirement, in which case it would inevitably be higher.
I think the key point there is, though, if you did a dense array, you lose that 6 cents for the agricultural adder, and without that 6 cents, it's difficult to make the project work. I'm not saying it can't. In the right scenario, it can, but it's difficult. The 6 cents makes all the difference in the world.
It is the largest adder in the program. There's one other, I believe parking canopies is also 6 cents, but it's significant.
Next one is, how come so many projects need fences around them?
Good question. So it's code, and you've got a couple of different options. You can either put a fence around it, or you can use what's called solar scrim, where you actually put a very dense mesh on the back of each panel to prevent anyone from being able to access the wiring. The third option is to make them tall enough so that they can't be reached. And that's the case with Million Little Sunbeams, and this design is that they are high enough off the ground where code allows them to be fence and scrim free.
Next one is, can Nate provide more specifics about the new equipment he had to buy for hanging under panels? Do his cousins have comments about the logistics management required?
Good question.
Yeah. I'll tell you, my cousins weren't super keen on driving their really large tractors through the system. So you'll see there that I have my smaller tractor. And I had to buy a new mower, rake, and tedder to do this work myself rather than having them do it. And they largely hay the rest of my fields. And so I had to spend about $18,000 worth of farm equipment to buy the smaller rake, tedder, and mower to get closer to the array. You know, now that I have those and I can pull the hay to the middle of the rows, they are more comfortable driving down the middle of the row with their larger tractor. And it's not that they can't fit under it. They can fit. They're just so nervous about hitting a pole, which I understand. So, you know, they're my cousins and I understand. And, you know, we work together. They hay the fields, and I appreciate that they do that. And I appreciate that they have the dairy farm next door and keeping the family tradition alive. So I had to make those extra investments to buy the mower, rake, and tedder that are a little smaller than what they had.
All right.
We have time for one last question.
One more. All right. Let's say, can you provide a cost differential for this system, more steel, labor, et cetera, relative to an industry standard design, such as an 18 to 24 inch drip edge, tighter spacing, et cetera?
Yeah, great question. I mean, it's hard to be specific because every system carries with it its own set of costs related to the site and any number of additional variables. I think it's safe to say, though, that these technologies, Nate, you might estimate, I'm going to say add as much as 30% to system cost, but they add a lot more than that in terms of added production.
That was the number I had in my head, Nick, from when we did this. There was 30% extra to do the trackers. Bifacial panels at this point are nominally more expensive, if at all. And the optimizers were not overly expensive. But if you take that extra 30% and then you lop off, you know, half of it or 40% of it because you got the tax credits and the depreciation for it, right? And then you add in the extra production that you get for it. And if you're getting the 6 cents a kilowatt hour because you're doing farming underneath, you start to do it all together. And I remember sitting in a room with Nick and the design team and saying, what else can we do to drive production here? Because every dollar that we were spending was adding kilowatt hours, and at this price per kilowatt hour, it just made sense. So
this system really is a case study. It really is a test case for these technologies, which per Nate's results over the past couple of years seem to have proved themselves quite well. And I want to underline what you said, Nate, because it's an excellent point. If you're spending 30% more, you're really only spending 13.5% more because you're only spending 45 cents on the dollar because of the federal tax benefits. So Nate's insistence that we move ahead with leading edge technologies proved itself in spades, and the system production is much, much higher than a traditional system. And I think that's about it. We are directly at the noon mark, and I want to thank all those who joined us today for taking time out to learn about dual use. Please feel free to contact us if you have any additional questions, or if you'd like us to engage with you in a specific discussion about a specific possibility. And probably best to send an email to info@sunbugsolar.com. Thank you all. Very much appreciate your attendance.
Thank you.
Bye-bye.